Hi, this is 12.3. Some more statistics. Right now, we're going to talk about the range. Okay, this is the range in statistics. If we have, for example, the highest temperature being 103 degrees, and we have the lowest temperature being 33 degrees, we subtract those two, and that's 70 degrees, and that's what we call the range. It's a range in temperature of 70 degrees. Okay, if we have data, here's some data. I'm going to just put in some numbers, 4, 2, 11, and 7. And we're asked to find the range. What we do is we take the largest number, which in this case is 11, and we subtract the smallest number, which is 2. 11 minus 2 equals 9. So that would be the range. Okay, next we're going to talk about the mean. We've talked about the mean before, but we have a symbol for it where we put a little line over the x. This means mean. We're used to seeing it to mean not that in probability, but with statistics, it just means we're looking at the mean. That's the symbol for it. And remember, the mean just means average. Okay, so let's take these problems right here, these numbers. Okay, so if we have these numbers, 4, 2, 11, and 7, and we want to find the mean is we sum them, 4 plus 2 plus 11 plus 7. We divide by how many elements we have, data points, 1, 2, 3, 4. We get 24 divided by 4, which equals 6. So our mean equals 6. Now, if we wanted to, we can find the deviation from the mean. Deviation from the mean. That would just mean how far off from the mean is each data point. So we're going to find the deviation. Let's make a little table. X is going to be our data point, and then x minus the mean is going to be our deviation from the mean. Deviation, we just subtract them. So in this case, we have a 4. These are our x's, our data points, 4, 2, 11, and 7. And we're going to deviate from the mean to see how far off they are from the mean. So 4 minus 6, which is negative 2. 2 minus 6, which is negative 4. 11 minus 6, which equals 5. And 7 minus 6, which equals 1. All right, now something that you ought to know, when we add these up, we get a negative 6 and a positive 6. It comes out to 0. So I just would like you to note that. Because it comes out to 0, we have no way of coming out with the average of the deviations doing it this way. We're going to do it another way later on. But for now, I'd like us to do another problem. Okay, so here's an example. Normally when you were in class, I'd have you do this in your group. So I'm going to put a G for in the group. And if you want to write the problem down and stop and try it out yourself, you can. Okay, so in this question, we're going to ask which point deviates from the mean the most. Which point deviates from the mean the most? Okay, so here we go. Here's some points. We have 778, 472, 147, 106, and 82. Okay, what we're going to do first is we're going to find the range. The range, we take the largest number, which is 778, and we minus the smallest number, which is 82, and that's 693. 2, we're going to find the mean. The mean, we would add all these up and divide by how many we have, which is 1, 2, 3, 4, 5, and the answer is 317. All right, now we're going to look at the deviations from the mean. Okay, so we have x minus the mean. So our x's, I'm going to write them out: 778, 472, 147, 106, and 82. And now we're going to take those numbers and we're going to subtract the mean. Okay, and that's 461. All right. Now if we took our calculator and just subtracted 472 minus 317, we get 155. 147 minus 317 is negative 170. 106 minus 317 is negative 211. And 82 minus 317 is negative 235. And once again, if you notice, if you add these, you will get 0. Okay, because when we add them, there's no way to say what the average deviation from the mean is. But before we do that, let's answer our question: which data point deviates from the mean the most? So which number is greater? It doesn't matter if it's negative or positive. Which number is greater of all of these numbers? This one's the biggest one. So 778 deviates the most from the mean. So the answer would be 778. Okay. All right. So once again, when we add these up, it equals 0, so there's no way to find the average of the deviations from the mean. But we're going to eventually do a formula that does that. But to get to that formula, I need to teach you some things. Okay? This sign, you've seen this before. All it means is to add things. We call it summation. It's actually a Greek letter, sigma. But what it means, I'll show you how it works. X minus x. Okay? This means we're going to add up all the deviations from the mean. So in our case, we would add up, well, if we didn't know what they were, just to show you what it looked like, we take the first one, 778, minus 317. That's the first one. Then when we'd add it, because that's what this means, we're going to add up the next one, which would be 155 minus 317. And then we do the next one and the next one and the next one. And as we know from what we just did, it all equaled 0. Okay? But let's try this. What if we took the deviation from the mean and squared it and add them all together? Okay? So what this would mean is when you subtract those two, we get 461, and we would square it. And then we add it to the subtraction of those two, which is 155, and we square it. And then we continue, negative 170, and we square it. And then we have negative 211, square it. And then we add that to negative 235 and square it. All right? And when we do all that, to save you some time, the answer is 365,192. So we're going to utilize this in the formula that's going to average all the means. And that's called the standard deviation formula. So I'm going to write that formula for you. Standard deviation. Okay. Now, what does standard deviation mean? It is the average deviation from the mean. The average deviation from the mean is what standard deviation is, okay? And this is the formula. It's a little s equals the square root of the summation of the deviations from the mean squared all over n minus 1. N is how many elements we have. I'll say that again. N is how many data points we have. Okay? So I'm going to put over here S just stands for standard deviation. Deviation. This we can think of as just sum of. We're going to sum everything. And N is the number of elements or number of data points. Number of elements. Okay? So we're going to do an example now utilizing the standard deviation formula. Okay. All right, so here's an example. We have the numbers 17, 18, 19, 20, 21, 22, and 23. Okay? The first thing we want to do is find the mean. When we add these up and divide by how many we have, the answer is 20. Okay? Another way of doing this, because they're consecutive order, the middle one is 20. That would be the average. Okay, now we're going to find the standard deviation, so we're going to make a table up. Okay, so we have x. We have x minus the mean. And then in this last part is x minus the mean squared. Okay, so listing the x's, 17, 18, 19, 20, 21, 22, and 23. Okay, so now we're going to take each number and subtract the mean. And that comes out to -3. All right, so if we do all this, the next one would be -2, -1, 0, 1, 2, and 3. Okay? Now it says to square them. So we would square -3, and that gives us 9. Square -2, and that gives us 4. And so forth. 9, 4, 1, square 0 is 0, 1, square 2 is 4, square 3 is 9. And then we add them up. When we add them up, that's what this means. The sum of x minus the mean squared equals, and we add all these up, and the answer is 28. So adding all those up is 28. Okay, so now with this, we can find the standard deviation. The standard deviation equals the square root of the sum of the deviations from the mean squared over n minus 1. So in our situation, we did all the work here. The answer is 28 divided by 7 minus 1, which is the square root of 28 divided by 6. And when you put that in your calculator, that comes out to be approximately 2.16. All right, so what did we find? 2.16 is the average deviation from the mean. And that makes sense. If 20 is the mean, look how close these are to 20. Very close to 20. Okay, now if our points were not close to the mean, we'd have a larger number. For example, if we had something like S was approximately 10.80, that means the points are not very close to the mean at all. So the smaller this number, the closer to the mean we are on average. Okay, so now I have your homework for you for this section. Okay, here's your homework for 12.3. 1, 3, 11, 13, 17, 21, and 20.